Okie dokie. Let's take a look at Stoichiometry I. I've got a writing instrument, my handy-dandy periodic table of elements with atomic masses on it, and a calculator. I'm ready to go. Number 1. Propane. CH38 combusts with oxygen to produce water and carbon dioxide. How many moles of propane will be required to react with 10 moles of oxygen? Well, the first thing we need in any stoichiometry problem is a balanced chemical equation. So let's do that. C3H propane, C3H8, combusts with oxygen. So C3H8 and oxygen, O2. So they combust to produce water and carbon dioxide. Water and CO2. There we go. All right, is it balanced? No, it is not. I have 3 carbons here, but only 1 carbon there. So let's put a 3 right there. Okay, so 3 and 3, that's good. I'll save the oxygens to last since it's all alone. I'll look at my hydrogens. I have 8 hydrogens here, but only 2 hydrogens here. So it looks like I will need a 4 right there. I now have 3 carbons, 4, 8 hydrogens, 8 hydrogens. But now over here I have 4 and 6 for a total of 10 oxygens. So I can fix that with a 5 right there. And there we go. Okie dokie. So how many moles of propane will be required to react with 10 moles of oxygen? So I have 10 moles of oxygen. How much propane will I need to combust them? Well, that's exactly the kind of question that stoichiometry will answer for us. Recall that with stoichiometry, once we have a balanced equation, the coefficients, we have a 1 here, we don't have to write it, but it's there. The coefficients on our reactants and products represent moles. So this is saying not only that propane plus oxygen yields hydrogen or water and CO2, but that specifically 1 mole of propane and 5 moles of oxygen will yield 4 moles of water and 3 moles of carbon dioxide. So that can be very useful to us if we know how to use it. So what we will do here is we want to find out how many moles of propane. So we start with what we do know, which is 10 moles of oxygen. 10. And I want to convert that to moles of propane. Well, normally I wouldn't have any way to compare oxygen and propane. They're 2 completely different substances. But now we do because we have a balanced chemical equation. Because what this chemical equation says is that according to this, 5 moles of O2, so let me write that down here, 5 moles of O2 is equivalent to 1 mole of propane. 1 mole C3H8. So my moles of oxygen would cancel out. I'm only left with moles of propane, which is what I want. So I just have to do the arithmetic. 10 divided by 5 is 2. So my answer should be 2 moles of C3H8. Sorry, I'm distracted. I'm watching my mom's dog. Daisy! Okay, sorry about that. I'm using a new microphone. I hope that wasn't too loud. Anyways, hey, stay in here. Good girl. All right, good girl. Okay, now, okay, so getting back to this. So, yeah, there we go. What we're saying is that 2 moles of propane will be required to react with 10 moles of oxygen. There you go. There's stoichiometry in a nutshell. Okay, how many moles of oxygen would be required to react completely with 3.0 moles of propane? Oh, I should point out back up here that, what about my sig figs? 10 moles of oxygen, that just has 1 sig fig in it. So my answer should have 1 sig fig, and it does, 2 moles of C3H8. So how many moles of oxygen would be required to react completely with 3.0 moles of propane? So again, we start with what we know. 3.0 moles of C3H8. And this time we're trying to find out how much oxygen we'd need rather than the other way around. So I just want to convert moles of propane to moles of oxygen. So I can do that easily enough because I know, based on my balanced equation, that 1 mole of propane is equivalent to 5 moles of oxygen. So I will just put 1 mole of propane down here in the bottom. And 5 moles of O2. All right, so my moles of propane will cancel out. I'm left with moles of oxygen, which is what I wanted. So it's just a matter of doing the math. 3 times 5 is 15. 15 moles of O2. And I should have 2 significant figures, and I do have 2 significant figures, so we're all good to go there. And finally, how many moles of oxygen must react with excess propane to generate 8 moles of water? All right. How many moles of oxygen must react with excess propane to generate 8 moles of water? All right. So I'm going to start with what I know. 8 moles of water. 8 moles H2. 8 moles of H2O. I'm trying to find how much oxygen that will need. So I just need to convert that using my balance formula to oxygen. So I'll put on the bottom here 1 mole of H2O and see how, oh, but this says 4 moles of H2O, alrighty, is equivalent to 5 moles of oxygen. 5 moles of H2O. 5 moles of oxygen. This is why I don't really like to do chemistry or math in pen, but pencil doesn't show up well enough on the video, so I apologize for scribbling here. 5 moles of oxygen is equivalent to 4 moles of water. So I just do the math. 8 divided by 4 is 2 times 5. My moles H2O cancel out. And that leaves me with 10 moles of O2. 10 moles of oxygen. All right. Now, note this phrase in this question here, excess propane. That's kind of important to this question because what if I had an entire tank of oxygen, but only just a small, tiny amount of excess of propane? Then I wouldn't use up very much oxygen at all. And conversely, if I had only a little bit of oxygen and all the propane I needed, I still wouldn't generate 8 moles of water. So this is saying that if I run through this experiment and generate 8 moles of water, how much oxygen must I have used? And this is without regard to how much propane I used. I don't care. That's why it says excess propane. I have all the propane I possibly need. It's just like when you go out in your back patio and turn on your propane grill some burgers, you have all the oxygen you could possibly need because you have an entire atmosphere's worth of it. So we don't have to worry about such things typically. But if I ran this and as a result I wanted to get 8 moles of water, how many moles of oxygen would I need? I would need 10 moles and all the propane I could use. Very good. That was number 1. Number 2. Methane, CH4, combusts forming water and carbon dioxide. How many grams of water can be produced from the complete combustion of 255.0 grams of methane? Alrighty. This problem's a little trickier because we are going to grams rather than moles. Just figure out how many moles you have, that's really easy. Grams just adds another little layer, but still, it's pretty straightforward. So let's start with the balanced chemical equation. So methane, CH4, combusts forming water and carbon dioxide. All right, so methane, CH4, it combusts. That means we're looking at oxygen here. And it forms water, H2O, and carbon dioxide, CO2. All right, Now, is it balanced? Let's see, I have one carbon. Oh, so far so good. Oh, but I have two oxygens and two hydrogens and four hydrogens. So let me fix that by putting a 2 right there. So now I have four hydrogens, everything's good. And with oxygens over here, now I have 2 plus 2 is 4. I just need to put a 2 right there. So once again, one carbon, four hydrogens, four oxygens, 4 oxygens. Good to go. So how many grams of water can be produced from the complete combustion of 255.0 grams of methane? So start with what we know. 255.0 grams of methane, CH4. Now, because my balanced chemical equation only tells me how each of these products and reactants correspond to each other with regards to moles, anytime I'm dealing with something in grams and I want to look at some other either product or reactant in the equation, I have to first convert it to moles. So that will always be our first step. So I want to convert grams of methane to moles of methane. So I know at the top here, I want to put 1 mole of methane. Now, so on the bottom, I need grams of methane, so we'll cancel out there. And what is the equivalent of 1 mole of methane in grams? Well, it would be the atomic mass of methane. So let's find out what the atomic mass of methane is. So I have carbon, I just have one of those, and I have 4 hydrogens. The atomic mass of carbon is 12.01. The atomic mass of hydrogen is 1.01, which times 4 would be 4.04. Add those together, that's 16.05. So that means 16.05 grams of propane is equivalent to 1 mole of propane. And now that means I can cancel out grams, I said propane, methane, grams of methane and grams of methane. So now that I've got my answer in moles of methane, I can now go back to my balanced equation and find any other of the ones I want. In this case, we just want water, so we're just going to go from methane to water. And according to the coefficients in my balanced equation, this tells me that 1 mole of methane, I'll put that on the bottom, is equivalent to 2 moles of water. And there we go. So now I get to cancel out a mole of methane and a mole of methane. And let's see here. I have, now my answer is in moles of H2O, but I want grams of H2O. So I've got to take one more step and convert this from moles of water into grams of water. And I can do that using the atomic mass of water, because on the bottom here, I can put 1 mole of H2O, and on the top, I'll just put the equivalent of 1 mole of water in grams. So that means I need to know the atomic mass of water. So water H2O has 2 H's and 1 O. The H is 1.01 each, so that's 2.02, and 1 oxygen is 16.00, 2, 18.02. So 18.02 grams H2O. Now my moles of H2O cancel out, and all I'm left with is grams of H2O, which is what I want, so we're good to go here, just a matter of doing the arithmetic. So I bring in my calculator, and 255, enter, 16.05, divide 2 times, and 18.02 times. Now, my calculator screen is showing me 572.59, and I should have 4 sig figs. So I will put 572.6. 572.6 grams of H2O. There you go. So, if I have 255 grams of methane and I combust it with oxygen, pow! that would generate 572.6 grams of H2O. All right, excellent. Number 2. Let me get rid of this piece of paper right here. Number 3. Magnesium reacts with oxygen to form magnesium oxide. How many grams of magnesium would be required to produce 2.50 grams of magnesium oxide? My first step with the stoichiometry problem is always to get my balanced equation. So here we go. Magnesium, that is Mg. That reacts with oxygen. So I'm going to react that with oxygen. Oxygen is diatomic, so that comes in as O2 to form magnesium oxide. So magnesium oxide. Well, if you look at your periodic table, magnesium, because it's in the second row, has a charge of +2 when it's acting as an ion, a cation, and oxygen has a charge of -2. So this will just be MgO, magnesium oxide. Are we balanced? 1 Mg, 1 Mg. Oh no. I need to put a 2 there, so I have 2 oxygens, but now because I put a 2 there, I need to put a 2 there. So 2 magnesiums plus oxygen yields 2 magnesium oxides. And that is a lovely little combination reaction there. Okay. Now, how many grams of magnesium would be required to produce 2.50 grams of magnesium oxide? Alrighty. So I know how much magnesium oxide I want to produce, so how much magnesium will I need? Classic chemistry question. So let's do this. Let's start with what we know. 2.50 grams of magnesium oxide. And I want to find out how many grams of magnesium I will need. So the first thing I must do is put everything in moles. So I'll take grams of magnesium oxide and convert it to moles. So here I will need 1 mole of magnesium oxide. And down below, I need the gram equivalent of 1 mole of magnesium oxide. Well, what is that, I wonder? Well, it is the atomic mass of magnesium oxide. So if I look at my little table here, it tells me that magnesium has an atomic mass of 24.31, and I know that oxygen has an atomic mass of 16.00, so that's 1, 3, and because that's 40, 40.31. So 40.31 grams of magnesium oxide. So now my grams of magnesium oxide cancel. I'm left with moles of magnesium oxide, but I want grams of magnesium, so I now use my balanced equation to go from 2, because I know that 2 moles magnesium oxide is equivalent to 2 moles of Mg in this reaction. So now I can cancel out my moles of magnesium oxide, and I'm just left with moles of magnesium, which, if that's what I was asking for, would be done. But we're not. We want grams, so we've got to take this one step further and convert this from moles magnesium to grams magnesium. So on the bottom here, I'll put 1 mole of magnesium. You see how that's gonna cancel out there. So up here, I just need the atomic mass of magnesium, which we already know is 24.31 grams of magnesium. And yes, you do want to get in the habit of labeling everything along the way. That's why, should you make a mistake, you'll be able to find it easily. And if you do this, then if your units are working out, then you can be assured, for the most part, that you probably have the problem right. It's just a matter of the arithmetic now. And indeed, I started with grams of magnesium oxide and converting that to moles, converting that to moles of magnesium, back to grams. So it looks like my answer is going to be grams of magnesium, which is what I expected. So let's do the math. 2.5. Enter 40.31. Divide the 2 moles of magnesium, 2 moles of magnesium oxide. That's a wash. That's just 1. So 24.31 times. Okay, my calculator is showing me 1.5076. I should have how many? 3 sig figs, 2.50. So 1.507 will come out as 1.51. 1.51 grams of magnesium. Wonderful. Okay. B. How many grams of oxygen would it take to react completely with 1.18 grams of magnesium? Alright. So we have 1.18 grams of magnesium. I'm going to know how much oxygen that would require to react with. So the first thing I want to do, as always, is convert this to moles of magnesium. So 1 mole of magnesium. And I already know the atomic mass of magnesium is 24.31. Now, I can use my balanced equation to go from magnesium to oxygen. So my balanced equation tells me that 2 moles of magnesium, I'll put that on the bottom so it cancels out with that, is equivalent to 1 mole of oxygen. And finally, I'm asking for grams of oxygen, so one more step here. We will go from moles of oxygen to grams of oxygen. Oxygen has atomic mass of 16, so O2 would have an atomic mass of 2 times that, or 32 grams O2. So let's see, my grams magnesium cancels with grams, my moles magnesium cancels with moles, my moles of oxygen cancels with moles of oxygen. I'm left with grams of oxygen, which is what I want. So now it's just a matter of doing the math. 1.18. Enter 24.31. Divide. 2. Divide. 32 times. My calculator is telling me 0.7766. I should have 3 sig figs, so that will come to be 0.777. 0.777 grams of oxygen. Splendid. All right. C. How many grams of magnesium oxide can be performed if 0.875 grams of magnesium reacts with an excess of oxygen? All right, so here again, it's important that we have an excess of oxygen because I'm just saying I have this much magnesium and I want to react it. Well, the amount of oxygen I have will change how much that reacts. So if I restrict the amount of oxygen I have, I may not have enough to react 0.875 grams. So if I just have all the oxygen I need, I don't have to worry about that. And that's why we have XX oxygen here. Daisy! Okay, again, sorry about that. She's into something out in the kitchen. Okay, let's see here. So, 0.875 grams of magnesium. 0.875 grams of magnesium. I want to find out how much, if I have all the oxygen I need, how much magnesium oxide I can get from that. So, I will begin by first converting this to moles. So 1 mole of magnesium, and it's equivalent to 24.31 grams of magnesium, atomic mass of magnesium. So that means those will cancel out. Splendid. I want to find out how many grams of magnesium oxide. So I need to take this from grams of moles of magnesium to moles of magnesium oxide. And this tells me that 2 moles of magnesium is equivalent to 2 moles of magnesium oxide. So down here, 2 moles of magnesium, 2 moles magnesium oxide. And lastly, I want to convert that to grams of magnesium oxide. So down below here, let's put 1 mole of magnesium oxide up top. We'll put the atomic mass of magnesium oxide, which we already calculated up here in part A, 40.31 grams of magnesium oxide. Okay, so that cancels with that cancels with that. Grams MgO, which is what I wanted. So let's do the math. 0.875, 24.31 divide the 2 moles of magnesium oxide and 2 moles of magnesium. That's a wash. So 40.31 times 1.4508 0.875, so that looks like that should be I should have 3 sig figs, so 1.45 grams MgO. My fingers kind of goofed up there in the calculator process, so let me just double check my figures. 0.875, 24.31 divide, that's a wash, 40.31 times, 1.450. So 1.45 grams of magnesium oxide. There we go. Splendid. Problem 4. Potassium chlorate decomposes into potassium chloride and oxygen. How many grams of potassium chloride can be produced from the decomposition of 5.00 grams of potassium chlorate? All right, how many grams? So the first thing we need, of course, as always, is a balanced chemical equation. So potassium chlorate decomposes. Potassium chlorate. What the heck is potassium chlorate? Chlorate is ClO4, but what is its charge? I don't trust my memory on that one. I'm looking it up. So let's see here. Let's see. There it is. My periodic table of ions that I handed you guys out in class tells me that chlorate is ClO3. I was wrong. Good thing I checked. ClO3 with the charge of -1. ClO3 with a charge of -1. And of course, potassium, being in the first column, has a charge of +1. So potassium chlorate, KClO3, decomposes into potassium chloride and oxygen. So potassium chloride, potassium's 1, chlorine is -1. This is just KCl. And oxygen, which is diatomic, so that's O2. Now, is it balanced? I have 1 potassium, 1 chloride, 1 chloride. No, it is not balanced. But I can balance it easily enough because I have 3 oxygens here and 2 there. I just need a number those can both be. So let's put a 2 here. That will give me 2 potassiums and 2 chlorines and 6 oxygens. And if I put a 2 here, I have 2 potassium, 2 chlorines, and 2 oxygens. I need 6, so I'll just put a 3 right there. Very good. I don't know if you can hear that, but she's into something. Hang on a second. Daisy, come on. In here. Lay down. Be calm. Okay. Apologize for those interruptions there. Okay, so let's get to the task at hand. I've got my balanced equation. How many grams of potassium chloride can be produced in the decomposition of 5 grams of potassium chlorate? So I, of course, will start with 5.00 grams of KClO3. And I want to find out how much KCl that will give me. So the first thing I will do, as in all the other problems, is convert this to moles. So 1 mole of KClO3 is equivalent to how many grams of KClO3? Well, it's whatever the atomic mass of KClO3 is. So I consult my little periodic table of the elements here. I see potassium has a mass of 39.1, chlorine has a mass of 35.45, and oxygen, of course, has a mass of 16. Okay, this is probably not the best video I've ever made, but I'm soldiering on. KClO3. Okay, so I need to just add all those together. So potassium, as noted, is 39.10. Chlorine is 35.45. And 3 oxygens at 16 apiece would be 48.00. So that will be 5. And what I got here, 14 and 8. That's 2. Carry the 2. So that's 10, 11, 12. 122.55. 122.55 grams of KClO3. The atomic mass of that, 122.55. Now, I want to find out how many grams of potassium chloride I get, so I need to convert this from moles of potassium chlorate to moles of potassium chloride. And my balance equation tells me that 2 moles of potassium chlorate is equivalent to 2 moles of potassium chloride. And finally, the last thing I need to do is convert it from moles of potassium chloride to grams of potassium chloride. And moles of potassium chloride is, I'll just use my calculator, 39.1 and 35.45 plus, that's 74.55 grams of potassium chloride. Alrighty, now let's check my units. Grams of potassium chlorate, gone. Moles of potassium chlorate, gone. Moles of potassium chloride, gone. I'm left with grams of potassium chloride, which is what I want. So it's just the arithmetic. So let's do that. 122.55 divide. That's a wash. 74.55 times. Okay, how many sig figs should I have? I should have 3 sig figs. My calculator is showing me 3.041. So this will be 3.04 grams of potassium chloride. Splendid. How many grams of potassium chlorate are required to produce 3 grams of oxygen? So we start with what we know, which is 3.00 grams of oxygen. And I first convert that to moles of oxygen. So 1 mole of oxygen on the top. O2, the atomic mass, is 32.00 grams of O2. Using my balanced chemical formula, I can now convert from oxygen to potassium chlorate. This tells me that 3 moles of oxygen are equivalent to 2 moles of potassium chlorate. So 3 moles of oxygen, 2 moles of KClO3. And the last thing I will do is convert from moles of KClO3 to grams of KClO3. So I'll use the atomic mass of KClO3 for that. So 1 mole of KClO3, we already figured that out. It is 122.55 grams of KClO3. And so my units check out: grams oxygen gone, moles oxygen gone, moles potassium chlorate gone, grams potassium chlorate. It's all I have left. So let's do that. 332 divide. Oh, this is not a wash. So 2 times 3 divide. 122.55 divide. Looks like I have, oh my goodness, I get 5.09 times 10 to the minus 4. But hold the phone, I should have 3 sig figs, so that tells me I've got 5.10 times 10 to the minus 4. That is such a small number. I'm just going to double check my calculations. So 332 divide 2 times 3 divide 122.55 times. I'm glad I did. That number seemed way too small. I must have divided when I meant to times or something. That looks much more reasonable. 7.659. So to 3 sig figs, that will be 7.66. 7.66 grams of potassium chlorate. So if I have 7.66 grams of potassium chlorate and I decompose it, I will wind up with 3 grams of oxygen. And finally, last one here, 4C. How many grams of oxygen are produced from enough potassium chlorate to produce 4.00 grams potassium chloride? Oh, that's a good question. Does it mean we have to do 2 calculations? No. Because all this is saying is how many grams of oxygen are produced from enough potassium chlorate to produce 4.00 grams potassium chloride. I don't know what that is, but I know that whatever it is, it produces that. And with stoichiometry, if I know how much of one product I have, I can just use that to go straight to the other product. So I don't need to first figure out how much potassium chlorate this actually was. Yeah, save yourself a extra calculation there. So how many grams of oxygen are produced? Well, I'm going to start with what I know, which is 4.00 grams of potassium chloride. That's KCl. The first thing I do is what I do in all of these problems. I will convert that to moles of KCl. We've already figured out that the atomic mass of KCl is 74.55 grams of KCl. Now, my chemical equation tells me I want to go to oxygen, so 2 moles potassium chloride is equivalent to 3 moles of oxygen. And now let's see here, I want to go to grams of oxygen because that's what the question's asking for. So down here, let's put 1 mole of oxygen up here, the equivalent to 1 mole of oxygen in grams, which of course would be 32.00 grams of O2. All right, let's do the math. 74.55 divide 3 times 2 divide 32 times 2.575. I should have 3 sig figs. That will be 2.58. 2.58 grams of O2. Whew. Where's the lid to my pen? All right. Now, that was just stoichiometry 1 of 7. Yes, that's right, 7. And this is the most basic stoichiometry gets. It can get more complicated than this when we start talking about limiting reactants and calculating percent yields and all that, but that's down the road. So for now, let's just focus on what we did here. Balanced chemical equations, converting to moles, all that stuff. All right? Splendid. Well, if you have any questions, you know how to reach me.